Hi everyone, today we're going to be going through the steps of how to get started in Python on a Mac. However, a near identical process can be followed if you're on Windows. The first thing we are going to do is go to Google and search for Python download. This will bring you to python.org. From here, you can simply download the latest version of Python, which is currently Python 3.8.3 for me. However, if you're looking for an alternative version of Python, such as the legacy Python 2, there is a download drop-down list that you can click through to find what you're looking for. Now that our file is done downloading, we can go to our download files and run the file. There are a couple of confirmation screens that we can just click through. So, once the installer has completed installing Python on your Mac, we can move on to the next step, which is selecting a text editor to use, so that you can actually enter and run your Python codes. We could use something simple like Notepad to run the Python code, however there are free alternatives that will make our lives much easier. These programs are called IDEs, which stands for an Integrated Development Environment. These allow us to easily troubleshoot pieces of our future code, making our lives much easier. There are numerous great Python IDEs, however the most common one I've found is PyCharm. PyCharm looks great and is relatively easy to learn, so let's go back to Google and download PyCharm. When we get to the PyCharm download section, we can see that there are two options. For the vast majority of individuals, the free and open source community PyCharm is all that we need, so let's download that. Once that is done downloading, we can run the .dmg file that we downloaded and drag that over to our applications folder. Now that we have the latest version of Python and PyCharm installed, let's open up PyCharm and quickly take a look. So we can see once we open PyCharm, it will prompt us to start a new project. So let's do that, and of course you can name the project whatever you please. So on the left, you can see the folder that we just created. On this folder, we can right-click and select New, then Python file. In future videos, we'll get into the Python programming language, but for now, just to ensure that everything is working correctly, let's print test to the console. We can do this by typing all lowercase, print, bracket, quotation mark, test, quotation mark, and bracket. And at the bottom, once we click run, we can see that the test was properly printed to the console, so we know everything is working correctly. Hi everyone, today we're going to be talking about what strings are in the Python programming language and why they're important. Strings are generally described as a sequence of characters, meaning it is just a group of letters, numbers, spaces, etc. combined together. Therefore, through using strings, we can form sentences or words within our programs. So let's think for a minute. Why is this necessary? Well, let's say I wanted to create a website where users could log in. It would be pretty silly if I only allowed users to create usernames and passwords based strictly on numbers. Therefore, we want to give them the option to input their username and password as a string and store that for later. There are several different ways to tell Python that you want to create a string. A single quotation mark or double quotation mark are the most common approaches taken. Many people, including myself, typically use a double quotation mark though as a possessive word like Mark's shovel, will cut the string short as the apostrophe on Mark's is seen as the end of the string. Another way to create a string from another data type is by typing the variable name, let's call it new string, equals str for string, and then brackets around the data type that we want to change. This doesn't replace our old variable, it simply creates a new string variable with the data now being a string and not an integer. Lastly, if you have a very long string and you wish to move it to the next line, just make sure you're in the quotation marks and hit enter, and PyCharm will continue your string on the next line. There are two important things I wish to add. Although numbers can be stored as a string, we can no longer alter them as if they were a normal number. This is because strings are what is called immutable, which means you cannot simply change it once it is created. So, as you can see here, I cannot simply add string 1 and string 2 together to get 4, as they are strings and not integers. This would be akin to adding a plus a, and it doesn't really make sense, so Python just does what it's told and combines them. So that is why we get 22 as our resulting variable. What we just did is called concatenating strings, which essentially means to combine them. To do this, you simply put a plus sign between the string variable names or between the two different strings quotation marks. This could be very useful, for example, if you have a first and last name box on your website sign-up sheet and you wish to store the user's name as their full name. Hi everyone, today we're going to be learning the rules around storing variables in Python, and in doing so, present some examples of correct and incorrect variable naming. Rule 1. The variable must begin with either a letter, which could be either uppercase or lowercase, or an underscore. The big thing is you cannot use a number as the start of a variable in Python. As you can see here, there's no problem with the first three variables we've entered as they're all valid. However, once we add the fourth variable, which begins with a number, we will be returned a syntax error, which we will discuss further in the next video. As we have talked about in the previous video, the quotation marks around our newly stored variable value is to tell Python that the variable is a string and not a number. To store a number, we do not need the quotation marks. Rule 2. Variables are case sensitive. As you can see here, I have two variables that are basically the same. However, the first letter on the second variable is capitalized, which makes the two variables completely different. We can confirm this by simply printing both variables to the console and confirming that they are not the same. Rule 3. Like many programming languages, there are certain words that cannot be used as variables as Python already has something assigned to them. These are called keywords, and there are 33 of them in Python. Some of these words include break, if, function, etc. A complete list of Python keywords can be found in the description below or by simply Googling Python keyword list. Rule 4, although it is not really a rule, more of a best practice. Although variables can be as long as you want, it is best practice to make your variables consistent and shorter if possible. Like here, I'm naming YouTube channels. I could have a variable called channel_1, channel_2, etc. And since we are being consistent, this is acceptable. However, although you could, it would make your life a lot easier if you didn't use channel_1 and then capital channel 2 for the second one. As long as you follow these 4 quick rules, you shouldn't have any problems when defining your variables in Python. Hi everyone, today I'm going to explain what a syntax error in Python means. A syntax error is likely going to be the most common error you encounter while learning Python, or any new programming language for that matter. First, let's give a definition of syntax. Syntax is essentially a set of rules that we must follow in language, coding, or really any form of communication. Like speaking, our program can only understand what we tell it. If we tell it something incorrectly, the computer won't know what you mean. This would be like if I told my friend, "Hey, lunch due Thursday, you?" Obviously, my friend will have no idea what I'm talking about, and we can think of programming in the same way. So a syntax error in Python arises when Python sees a piece of code that it doesn't recognize as a valid Python code. So, anytime you have an unrecognized variable, a misspelling, an extra word, etc., a syntax error will arise. So, if we denote strings with only a single quotation mark, any possessive term will result in a syntax error, as a string is cut short and there are extra words that Python can't recognize, as it doesn't understand that they are supposed to be within the string. So, in summary, if you have a syntax error in your code, just look at the line where Python is spotting an error, and there will likely just be a small error in indentation, a typo, a missing comma or colon, or some other minor error that Python is not recognizing as Python code. Just one final note, if you're having a difficult time identifying the syntax error, do not get frustrated because you are certainly not the first or the last. Python's syntax errors are generally regarded as the least specific type of error, and they're not always obvious what Python is not liking. Hi everyone, in this video I'm going to quickly go through what an f-string is in Python. I just want to quickly add, Python f-strings were introduced in Python 3.6, so if you're using an older version of Python, you're going to want to update that before proceeding. The F stands for format, so we could also call these format strings. F-strings allow us to easily add our variable directly within our strings. So how does this work? Well, first let's store two variables. Let's say first and second part of our YouTube name. Now, without the use of an F-string, we will have to type YouTube channel equals first part plus to concatenate the strings, and then a quotation mark with a space, quotation mark, plus the second part variable. Once we print this, we will get our desired name back. However, this is not an f-string. To implement an f-string, we initialize our YouTube channel variable again, equals f, to tell Python that we want an f-string, and then we enter our variable names inside of curly brackets so that an f-string is formed. So as we can see here, when we print these two strings, the regular string and the f-string, the same result is achieved. One other quick thing I wish to add is all Python is looking for in the curly brackets is something to evaluate, which we will typically enter as a variable. However, we could also add in a math operator. So we could have, if I work 10 hours a week and make $20 an hour, I will have 10 times 20 within the curly brackets at the end of the week. So once we print this, we get our full statement. So in summary, the benefit of f-strings is that they allow us to enter variables directly into our strings, which is extremely useful in Python. Hi everyone. In this video, I'm going to be talking about lists in Python. What are they? What are they good for? And how do we implement one in our Python code? In Python, lists are a type of data that is an efficient way of storing larger amounts of data. Typically, we want the information to be related some way as well, otherwise it could get very confusing. So if we wanted to create a website and we wanted to attribute each user of our website as a list, we could combine all that user's information into one consolidated list. The best thing about lists is that we can store any data type within the list that we want to. So it could be a string, a boolean, an integer, etc. Now that we have an idea of what lists are in Python, how do we go about implementing and recalling one? To implement a list in Python, we initiate it the same way we would a variable. So let's call it YouTube channel. Then we put an equals, square brackets, and then we insert our pieces of data with a comma separating each piece of data. So let's say I want my name, then my subscribers, and then my total channel views. So since my name is a string, I must use quotation marks, and then the last two pieces of information are just integers, so quotation marks are not needed. Then we need to end the list by using another square bracket. Now let's verify what I just stated. In that Python has no problems with users entering different types of information into a single list. Therefore, let's print the first two pieces of information and check their data type. Firstly, I just want to add that the position a piece of data has in a list is called its index. And in Python, these always start with 0 and not 1. So if I want to recall the name, let's print the name of our list, square brackets again, and a 0 since we want the first item in the list. And we'll also add an extra line to check the type of the data. Now let's repeat what we just did for the number of subscribers. Once running the code, we can see that everything was returned properly and as expected. Another interesting thing to note is that if you want to print all pieces of data after a certain index, you can just add a colon after the index position. There are also ways to alter your list using list functions, however, this will be further introduced in the next video. Also, if you wanted to, you could just print the whole list by stating print and then the list name. Hi everyone, in this video we're going to be talking about list methods in Python. Specifically, what are list methods, why are they beneficial to us, and how do we go about implementing them into our Python code. If you have seen our previous video on lists in Python, you know that they are an efficient way of storing large amounts of data of varying data types in one consolidated area. Because lists are immutable data types, that means that we can alter them. So, what if we wanted to alter the stored data somehow, or even combine two lists together? Well, that is where list methods come in. List methods are quick and efficient ways to alter or adjust our lists. So let's say we have two lists. The first list is some employees from company 1, and the second list is some employees from company 2. Let's say the company 1 purchased company 2, and we want to combine these two lists. How do we go about this? Well, using list methods, it is simple. We enter the list we want to add something to and put a period, extend, and the list we want to add on to the end in the parentheses. Once printing the newly altered list, we can see that we have now combined the lists. Therefore, as you can see, list methods are extremely effective and quick at altering our lists to our liking. Let's keep looking at a few other examples of list methods. There is also .append, which will allow you to add what you enter as a single index position within your primary list. So, if we wanted to store company 2 as a single index, we could type company1 append and company 2 in parentheses. Therefore, once we print, we can see that the square brackets indicate our list is a single index position. Append is most commonly used, however, to add a single item to the end of the list. Let's say company 2 is hiring Peter. We can add him to our list by typing company2.append and put Peter in the parentheses. Now, once we print the list, we can see that Peter has been appended to the end of this list. Another useful Python method is .insert, which will allow us to add any item we want into any index we want, whereas append will always add it to the end of the list. So let's say we want to add Marvin at the start of our company 1 list. Well, we type company1.insert, round brackets, the index position we want to add our new data, comma, and then the piece of data that we want to add. So once printing, we can see that the newly adjusted list, Marvin is now at the beginning of, because we entered him as index 0. To remove one specific item from a list, we can use the pop method, which is done by simply putting .pop and an index number into the parentheses. Once printing, we can now see that our list is one item shorter, and the name that was in index 0 is now gone from our list, which is what we wanted. Also, if you wanted to reverse the order of a given list, this can be done using the .reverseList method. Another interesting list method is count, which can tell you how many times a given piece of data occurs in a given list. So let's look at a third company with many employees, and we want to know how many Marks work at this large company. Well, we can create a new variable called Mark, and using the countList method, quickly check how many Marks work at the company. Similarly, the index list method will return the lowest index position that a given piece of data appears. So we can see that the first mark appears at an index of 0, which we know is true. I hope this gave you a good introduction to list methods and made it clear to why they can make our lives with lists much easier within Python. Hi everyone, in this quick video I want to talk about writing comments in Python. We will talk about how and why we write them, and what are some of the best practices to writing comments in Python. To begin a comment in Python, you simply put a number sign or a hash character anywhere that you wish, and the remainder of that line will be a comment. But what does this newly formed comment mean exactly? Whenever we place the number sign or hash character in a given line, the remainder of the line will be ignored by the Python interpreter. So, as you can see here, our comments have no effect on our code. A comment in Python is a line of code only for the programmer to view, which allows them to better understand what is happening during a certain chunk of code. Comments are essentially a way of explaining our code in plain English. Comments are extremely simple to implement and are extremely useful, especially during complex pieces of code or particularly long pieces of code. So, now that we know how to implement comments in Python and what they are, let's talk about some of the best practices when writing comments in Python. We want to keep our Python comments short, concise, and to the point. This allows you and others viewing your code to quickly understand what a chunk of code is about and why it is there. We try to keep our comments directly to the point to still get our point across while maintaining as much simplicity as possible. Number 2, you want to eliminate redundancy in your comments if you can. Try to explain everything only once and as best as you can. This will keep your code looking clean and well explained to yourself and anyone else who may be viewing your code. Number 3, you should use relevant variable, function names, etc. to eliminate the need of extra comments where you otherwise wouldn't need them. If we're saving friends' names in a list, we should call that list friends list or something similar, and not something generic just like list1, as list1 would require a comment to explain what the list is about. Number 4, if you have a rather long comment, it should be broken up into 2 separate lines. This is called a multi-line comment. To implement a multi-line comment, you just need to ensure that the secondary line also has a number or hash character. If you're experimenting with your code, which we often do, an excellent way to comment and uncomment large chunks of code is by highlighting the code you want to comment and hitting Command / on a Mac or Control / on a PC. If you wish to uncomment, just repeat this. So, in summary, comments are phenomenally helpful to you as a programmer and anyone else viewing your code. However, just make sure that you keep them short, concise, and non-redundant. Hi everyone, in this quick video we're going to be talking about what an index error in Python means and how we can resolve them. So let's say we have these 3 employees at company 1, and we want to print out that Mark is our employee of the month. So, using an F string, we can print the following line. We would expect our print statement, however we are returned an index error, but why? Remember, index just means the position a given piece of data has within a list. So, an index error will arise when you try to call a non-existent index within a Python list. The important thing to remember about Python is that indices always begin with a 0 and not 1. So, our print statement here is trying to find the 4th index, the 4th position, 0, 1, 2, 3, in our list that simply only has 3 possible positions. Therefore, the index error in Python is simply telling us that we are trying to get a value from a position that just doesn't exist within the given list. Another way you could achieve an index error is by trying to call an index position within an empty list. This is the same reason as earlier. We are trying to retrieve a piece of data that doesn't exist within our list. The easiest way to resolve these sorts of errors is to ensure that the index position you are trying to call or retrieve is a valid option. If I run into these errors, the easiest way to fix it is to either print your list and ensure that your list looks the way that you expect it to, or to check the length of your list and ensure that the value you're trying to call is between 0 and the number you retrieve from the len function. I found that these errors are most common for individuals who are either new to Python or coming from another programming language where the counting of the positions begins with 1 and not 0. Hi everyone. In this quick video, I'm going to show you how to organize lists in Python. As Python lists can become extremely long, ensuring that all of our information is where we think it is very important. Before we begin, let's create a list of employees that work at a given company, and add a print statement so that we can see how our list organization works in Python. We can organize Python lists in several ways. First, let's begin by saying we want to organize our list alphabetically. We can accomplish this by using the sort method. If you have seen my previous video on list methods, then you know how simple they are to implement. We simply type our list name, .sort, and that's it. As we can see here, the newly altered list is certainly arranged alphabetically. This way of organizing lists will permanently alter our list, and we cannot revert it back to the original. So, this method is ideal if you are never going to need the previous list configuration again. What if we wanted to sort reverse alphabetically? Could we organize our list this way as well? Well, of course we can, but how? Let's begin by starting the same way we did using the sort method. However, this time, instead of an empty parenthesis, let's add reverse equals true inside them. This tells Python you are looking to reverse the method, which in this case reverses the names alphabetically. Another interesting way of organizing your Python lists is simply reversing the order of your list. This is done through the reverse method. Simply type .reverse and empty parentheses, and then our list will now be reversed. To return our reversed list, we can simply repeat this line. What if we don't want to actually change the order of our list? We just want to print it in a certain configuration. Well, using the sorted function, we can do this. I will talk more about the difference between methods and functions in Python more in a future video, so if you do not currently know the difference, do not worry. To use the sorted function, we simply add sorted, like so, into our print statement. And then to prove that this didn't permanently change our list, let's just add a regular print statement. And there we go. As you can see here, our first print statement returned the organized list, and our original list is still in the same order. You can also reverse this function by adding a comma and reverse equals true with a capital T on true. I just want to add something really important. In Python, you cannot sort a list with string and numerical data types together. So if we wanted to add, say, an integer, like 3 to our list, and try to use the sort function, it will return us an error. We can only use this method when our lists are all either numeric or strings only. Lastly, if you're going to organize a strictly numeric list, everything I presented will work, just the list will be organized from lowest to highest numbers in the sort method and not alphabetically. Hi everyone, in this quick video I want to talk to you about the use of for loops in Python lists. For loops are an excellent way to work through each index in a list and either perform an action on each index or first check a condition and then perform an action. So before we begin, let's do up a quick list with our company's employees. Now, let's say we want to go through our list and print that all of our employees are awesome. To do this, we will use a for loop. So, to initiate the for loop, we type for, and then some temporary variable name, which we will call employee. This is what Python will temporarily store the index value in as it goes through each loop. Therefore, each loop, it will take on the next index's value. Then, to finish the for loop, we type the list that we want to loop through and a colon. Now, we indent the following lines. This part is very important. And we just type the code that we want to apply to each item in the list. Since we said that we want to print all of our employees are awesome, let's apply an if statement and do that. Now, we can see that all of our employees know that they are awesome. It is important to recognize what Python is doing during this for loop. Python will first begin at the 0th index, and since there is no conditional statement, take its value, therefore employee is now equal to Mark, and apply that Mark value to our subsequent if statement that calls for the employee variable, which we said is Mark. Once this print statement is completed, Python will move to the next index position and repeat the process. What if we only wanted to recognize Mark's hard work and give him Employee of the Month? Well, we could accomplish this by adding a conditional statement at the start of our for loop. A conditional statement will use a Boolean statement to return a Boolean value, which means that we will only ever get true or false back. This is accomplished through adding an if statement nested inside the for loop. Just please note the indentation I have used here, as it is very important. If your for loops or if statements are not properly indented, you will likely get an index error. Although, since conditional tests are case sensitive, we can add a lower method to ensure that no matter what capitalization was used within the list, we can still recognize the name Mark no problem. So if our employee variable ever equals Mark, then we will print that they are the employee of the month. Otherwise, we can say that the employee is not the employee of the month. There are tons of ways you can use this looping through lists, particularly with conditional statements. Not only can you use things like greater than, less than, or equal to, etc., you can also add an exclamation mark in front of the equal sign, which means not equal to. Also, you can check if an item isn't a list just by using the following Boolean expression. I hope this video aided your understanding of how looping through lists in Python works and how amazingly useful they can be. Hi everyone, in this quick video I want to talk to you about how we can check whether a certain piece of data is or is not in one of our Python lists. So let's do up a simple list of tools we have in our garage. Now let's say I'm going to work on a new project and I want to see if I have a hammer. Obviously this is a short list and bare bones code. However, imagine that we had a massive list where it would take a long time to scan through every item in our list. How do we quickly identify if the string hammer exists within our Python list? Well, we can use one of the Python keywords in, which allows us to simply search for a given value in a Python list, and it will return us a Boolean value, so true or false, based on if the item exists in the list or not. So to perform this, we simply type the item name we want, so hammer, in our list name, which we called tools. And since I want to output the answer to a console, I also have a print statement here. But if you wanted to perform some other action, once you get your Boolean answer, then you could also do that. So when we print this, we will get a true since we do have a hammer in our current list. Another method you could use is an if statement, which would look like so, which returns a true value if the string is present anywhere in the list, and a false value if the item is not in the list. You could also use the count method if you wanted to see how many times an item appears in a given list, like so. Or you can just print that the item is present if any value greater than 0 is returned for the count. Another cool thing we can do with our Python list is check if a certain value currently exists in the list, and if not, we can automatically append that item to our list. So let's say I'm about to buy a new measuring tape and I want to check if I currently have one, and if not, I will add it to my tool list. So we can do this through a simple if statement. So once we print this, we can see that the measuring tape is now appended to our list. So what is happening here is we are telling Python to scan through our list and see if measuring tape is present at any index position within the list. And since it is not, it returns a true value to our if statement and activates the append piece of code. We can see by removing the not that if a false value were returned in this if statement, the code would not be active, and as expected, measuring tape will now not be appended to our list. Thank you for checking out this video, and I hope it helped your understanding of identifying if an element exists in your Python list or not. Hi everyone, in this quick video I want to talk about what Boolean expressions are in Python, how they work, and then give you a few examples of how Boolean expressions can be useful in your code. First, let's begin by discussing what a Boolean expression even means. A Boolean expression is a common term among programming languages, and it is another way of stating a true or false condition. So, we state something that is either going to give us a true answer or a false answer, and that answer, whether it be true or false, is called a Boolean value. Just please note that a Boolean expression can only ever give a true or false value. There are no other possible answers to a Boolean expression. So, now that we have a rough understanding of what a Boolean expression looks like in Python programming languages, how do we enter one and how do they work? To begin a Boolean expression, we can enter one of the many conditional testing operations we have at our disposal. So, by that I mean we can check if a value is equal to another value like so, or we can check if one numeric piece of data is larger or smaller than or equal to another one. We can also check if an item is in a given list, etc. As you can imagine, there are tons of amazing ways that we could implement these Boolean expressions into our code, and even if you haven't started programming much yet, you will quickly learn that simple true or false conditional testing is quick, easy, and extremely useful in many programming languages. Let's perform a quick example using a Boolean expression so that you can see how they work. So, let's say you are developing a program for a veterinarian that wanted to see what pet someone has, identify the pet's name, and tell the vet what time the person's appointment is at. So let's just create two simple lists representing two clients. Now we can start an if statement. Let's first identify whether the pet is a dog, a cat, or something else. We can do that through the following if statement. If the string dog appears anywhere on the list, then this Boolean expression will be true, and the piece of code nested under this Boolean expression will become activated. However, if the person doesn't have a dog, then Python will skip this nested piece of code and move on to the next line. Therefore, after checking the animal's type, we can simply tell the vet what the pet's name is and what time their appointment is at. Now, we could perform this action for the two clients and print to the vet essentially their schedule for the day. Obviously, this code is inefficient and a little silly. However, it should give you an idea of one of the many ways that Boolean expressions can be used and how they operate in Python. Hi everyone, in this quick video, I just want to talk about what an indentation error in Python means. Following a for loop, an if loop, a function creation, etc., Python requires all the nested code related to the loop, function, etc. to be indented the same. An indentation error is just as it sounds. It occurs typically when an indent is forgotten following a statement that needs some subsequent code. Python won't accept our print statement since there is an indent missing. It will return us an indent error. However, if we add even a single space, it will resolve the issue. Another problem is your indentation must all be the same. As you can see here, my first print statement is only indented a single space, whereas my second print statement is indented through the tab button. Therefore, I always recommend just using the tab button as it looks nice and ensures that all the indentation is spaced correctly. So, in summary, if you have an indentation error in Python, just ensure that you have proper spacing in your nested code to your loop, function, etc. Thank you for checking out this video, and I hope it helped your understanding of indentation errors in Python. Hi everyone, in this video I want to talk about what the range function in Python is, and how it can be extremely useful in your Python codes. The range function is one of the many ways to generate sequences of numbers within Python. So, you specify a given range, so let's say we want a list of numbers from 1 to 10, we could say something like, for number in range 1 to 11, print number. So, the first argument that we give in the range function is our starting number, so we will begin at 1. And then the range function will count by 1 until it reaches the second argument, which is our stop number. So our range will never include that stop value in our list, since we're telling that where to stop counting. So Python is counting 1, 2, 3, etc. up by 1 every time until it reaches the second number inside the range function. Then it will stop counting. That is why for your stop number, you use the number you want plus 1. This is equivalent to setting up our desired range inside a variable and applying it in the following way. Another way to implement the range function into your Python code is through entering a single argument into our range function, and that number will simply act as our stop number, and it will begin at 0. So we could create our simple 1 to 10 sequence of numbers through the following piece of code. And this should make sense, right? We are creating a sequence starting at 0, counting by 1 until we reach our stop argument. What if we wanted to count by something other than 1 though? How do you think we would go about that using our range function? Well, through the addition of a third argument, we can control how large every step between our start and stop arguments are. So, let's say for our 1 to 10 list, we wanted to count by 3 instead of 1. Well, we just repeat what we had earlier, but simply add a 3 as a step argument. Therefore, we only get 1, 4, and 7 because another 3 step will put us at our stop argument, which tells Python not to add any more numbers to your sequence. You could also begin at a larger number and take steps backwards if you wish as well, through the use of a negative step argument. Now that you have the fundamentals of the range function down, you can begin to explore all the ways that it can be useful to you when coding. Like, for example, let's say we're selecting which friends we are going to invite to a birthday party, and since we can only invite so many people, we want to invite every second person in our list. Well, after making our friends list, we create a temporary variable called invite in the range of 1 to the length of our friends list. Then our third argument, which remember is our step argument, is 2. Then we can use a simple if statement to tell our selected friends that they are invited to our birthday party. I just want to state 2 important notes. Firstly, if you enter a float number, a number with a decimal, as your start, stop, or step argument, you will be returned an error stating that the integer value was expected, as the range function can only accept integer arguments. Secondly, if your step value is 0, you'll be returned a value error, so be careful not to do that as well. Hi everyone, in this video I want to talk about what a tuple is in Python and what exactly it means. A tuple in Python is very similar to a list except for one thing. The values within a tuple cannot be changed. Therefore, we can call tuples immutable lists, which means that the objects in the list cannot be changed or altered. Tuples are ideal for things that you know are never going to need to be changed, such as people's birthdays, dimensions of something you're creating, a spawn in a video game, etc. To enter a tuple in Python, it is the exact same as when we created lists, except we are going to use round parentheses instead of square ones. So we enter a variable name for our tuple, equals, and then enter our immutable list. To access elements in our tuple, we use the same syntax we used in our list. So if we want to access the first element in our friend's birthday tuple, we do the following. But if we remember, when using list, we can alter the data contained in a list. So if we had some piece of data that we needed to change in our list, we can simply access that element and change it, since lists are mutable data types, meaning that they can be altered. However, like I said previously, if we try that with our tuple, which remember is an immutable list, or alternatively said, it is a list that cannot be altered, we will be returned a type error. Other than altering elements in our tuples, for and if loops, list concatenation, list slicing, and everything else you previously learned about lists will all work with tuples. So, for example, if we wanted to print the dates of our friends' birthdays, we could print a simple loop like so. Another interesting thing to note is that although a tuple's elements cannot be altered, you can, if you wish, completely overwrite the tuple by defining a new tuple with the exact same variable name. This will essentially overwrite the previous data that was stored and completely replace it. If you wish to create a tuple with a single element, just note that you need to place a comma after your one element, as this is a requirement for tuples. Hi everyone, in this video I want to talk about if statements in Python. We will talk about what they are used for and how you can implement them into your Python code. So, an if statement in Python is basically a way of checking if a conditional test, so if something is true or if something is false, then do something. And that's really all if statements are. They tell Python to activate a piece of code if a certain condition is met. So, now that we have a rough understanding of what if statements are in Python, let's go through a few examples. To begin an if statement, you type if and then your conditional test, whatever that may be. It could be if one number is greater than another, if one value is equal to another, etc. Then you put a colon to indicate to Python that the following lines will be the do something portion that gets activated if your conditional test is true. So let's start simple. Let's say that we have a variable that keeps track of the current day of the week, and we only go out to eat on Fridays. So let's create an if statement that tells us if we can go out to eat or not. So as you can see here, it is indeed Friday, so our conditional statement is true, and we are returned the statement that we can go out to eat, which is expected. However, what if the day of the week was not Friday? Well, as you can see here, we get returned nothing from our Python code. Well, that's not really ideal. So what we can do is create an if-else statement. An if-else statement in Python tells it to check your initial if condition, just like before. However, if it is not true, you can tell Python to do some other action. So, since it is not Friday, we can tell ourselves that no, we cannot go out to eat that day. If you wish to have more than two possible options, there's also if-elif else chains, which can really have as many conditions for a single test as you want. So if we get a pizza at the store, let's say on Wednesdays, let's add that statement to our program using an elif, which just means else if. So if our initial condition is true, it'll activate the first block of code. If not true, it'll move to the elif condition and so on until it reaches a condition that is true. Just one final thing to note is that as soon as our Python finds one condition that is true, in your if, elif, else chain, the remaining part of the chain will be skipped, so Python will only process one test per loop through your chain. Hi everyone, in this video I want to talk to you about dictionaries in Python. In particular, we'll talk about what a dictionary in Python is and how you can implement them into your Python codes. So, a dictionary in Python is quite like it sounds. If you think about what a dictionary is, it's a word and then the meaning of that word beside it. Well, in Python, the word you look up is called the key, and the meaning or association of that key is called a value. Therefore, every key has a value paired to it. These are called key-value pairs. So, what do these even look like in Python, and how do we implement them? Well, let's just say you want to create a dictionary that stores some key metrics from a YouTube channel. Let's name it YouTube Metrics, and to begin our dictionary, we use these curly brackets. Then you enter each key-value pair like so. So just notice that for string values, we need to use single quotation marks, and for integers, we do not need them. So we basically have a key like name, subscribers, and views, and then the values associated with those after the colon. And as you can see here, you separate the key-value pairs through a comma, much like we did in lists. To add another key-value pair to a dictionary in Python, all you need to do is put your dictionary name, put the key in square brackets, and equals the value pair of that key. As you can see here, when we print the dictionary, the watch time metric was appended to the end of the dictionary. If you want to call any item in your dictionary, you will be calling the key and being returned the value pair. So if you want to say how many subscribers we currently have, we would do the following. And as you can see here, we are clearly returned the value pair and not the key, which should make sense, right? When you look up a certain word in the dictionary, you're looking for the associated value to that word and not just that specific word. Dictionaries in Python are the exact same way. To remove a key value pair from a dictionary, all you need to do is put del, the dictionary name, and then the key to the key value pair that you want removed. As you can see here, when we print the list, the watch metric is now gone. Lastly, if you wish to alter any of the values in your key value pairs, all you do is the exact same thing by adding a new key value pair, except is use the same key and overwrite the value with your new value. Hi everyone, in this video I want to talk about what while loops are in Python, what we use them for, and how we can implement them into our Python programs. While loops, much like if and for loops, check if a condition is true and continue to perform some operation as long as that condition is true. Using a while loop, our nested bit of code, that is, the code that will become active while a certain condition is true, will continually loop. So, let's say that we wanted to create a really simple timer that adds 1 second per loop. We only want our timer to operate while the timer is less than 5 seconds. So, we initialize our timer variable at 0 seconds. Then, we state that while our timer is less than or equal to 5 seconds, we perform the following chunk of code. Obviously, here this piece of code is super simple, but the same logic applies for longer repeating pieces of code. So, let's also add a print statement here at the bottom too, to ensure that we can see the loop working. Well, what if our testing condition is actually false? Well, let's remember what we did for our if statements. Remember that we added an else statement? Well, we can actually do the same thing for while loops as well. So, below our timer here, we can add an else statement that we will print to the user if we are above our time limit. Therefore, we can see that our timer will count up time, and when we exceed 5, we receive our timeout statement from the print console, which is what we were looking for. The use of these while loops in Python can be incredible. In the next video, we'll explore this topic further. Hi everyone, in this video, I want to talk about how we can begin defining functions in Python. So, what does a function in Python even mean? Think of a function in Python like a box that performs some action every time it is called. So, every time our Python interpreter sees our function, it'll go to that function and perform that code, and then it will return and continue on with our code. I think this is best taught through an example, so let's do that. Let's create a command that will accept a time in seconds and convert that into hours, minutes, and seconds. So, we start with the function by defining it. So, we type def for define, and then we give our function a name. So let's call it timeConvert. Then inside these parentheses, we need to define what are called parameters. These are values that we require from our user to use our function. So, if we had more parameters, let's say 3, then our user would need to give us 3 pieces of information, called the arguments, to satisfy all of our parameters. So the parameter are the values that we take in from our user, and the arguments are the values that our users give us to satisfy our parameters. So, in our function here, we only need a single parameter. That is, the amount of time in seconds that we are going to convert to hours, minutes, and seconds. And then using the following bit of code, we can find the amount of hours, minutes, and seconds for the given argument value. This bit of code here is explained in our modulo operator video, for which I will post a link in the description below if you're interested. Now, we have officially made our first function in Python, so let's test it out to make sure that it is working properly. So, to call our function, we simply type the name of the function and give our argument for the parameter inside the parentheses. As you can see here, at least in the PyCharm IDE, our timeConvert function autofills and it shows us how many arguments we need to give it, and the parameter name that it will take in as the argument. In the next video, we are going to go through how to accept multiple arguments and the difference between keyword and positional arguments. Hi everyone, in this video I want to talk about what keyword and positional arguments are in Python. Firstly, if you missed the previous introductory video on Python functions, I recommend you check out that first, and there will be a link in the description below if you're interested. So, when we have more than one parameter in a Python function, that means that we need at least two arguments from our user to satisfy those multiple parameters. But how do we enter those multiple arguments within the called function parentheses? Well, there are two options for us. We can use keyword or positional arguments. Let's first create a simple function with multiple parameters. Let's just keep it simple and create a greeting function that accepts the user's name and says hello to them. So we define our function using the def term and then enter a first and last name parameters that we need. And there we go. The function is now ready to be used. Firstly, let's talk about positional arguments. A positional argument is how it sounds. The argument positioned first in our function call will be assigned to the parameter positioned first in our function. So, since our function has first name as our first parameter, we need to put our first name, let's say Bob, as our first argument when we call the function, and likewise for the second argument for our user's last name. So, in summary, positional arguments just use the order of the arguments when calling the Python function. The other option we have to enter our function arguments is by using keyword arguments. This method for assigning arguments to a parameter is similar to how we define variables normally in Python. The benefit to this method over positional arguments is that the order in which you state your keyword arguments does not matter. So, to prove this, let's call our function again and input the arguments like so, with our last name argument first and the first name argument last. And as you can see here when printing, we receive the same output twice. So, in summary, both positional and keyword arguments can be used when multiple arguments are necessary for a Python function. Hi everyone, in this video I want to talk about how we can pass lists to Python functions. If you remember from our previous video, Python functions allow us to have a separated piece of code that we can call anywhere in our Python code, and upon being called, it'll activate the chunk of code that is our Python function. We also talked about what parameters and arguments of Python functions are. Just as a recap, remember that parameters are the pieces of information that our program requires, whereas the arguments are what the user gives to our function. So, in this video, what we are really doing is using a list as an argument to our Python function to satisfy a required parameter of that function. So, how do we go about getting our Python function to accept a list as an argument? Well, it is actually quite simple. So, to do this, let's create a Python function that prints out our grades for a given semester. Through this, we could create a few different lists that correlate to a couple different semesters in school. Obviously, this is a simple example, but it is just meant to give you an idea of how passing lists into functions works. Alright, so let's create our Python function called semester grades, which remember is initialized by this def term. Then we require two parameters. One is for our semester grades, and the other is for the courses taken in the semester. Since we are always going to have the same number of courses as grades, we need to extract the number of elements in either of our two lists. Then, just initialize an iteration variable I. So, let's say while I is less than our elements in our grade list, we print the following statement. Then we add 1 to our iteration loop counter, and this loop will continue while our iteration counter is less than elements in the grades list. That is all we need to do for now in our Python function. Alright, so now we need to create two simple lists that can be handed into our newly created Python function. Then, lastly, let's call our function and input our lists into our Python function using positional arguments. If you don't remember what positional arguments are, check out the video in the description below. Now, let's run our program finally. And we see that we receive a statement about all of our courses taken in a given semester like expected. Alright, so you may ask, what is the difference between this function and the ones we used previously, where we only took in a single argument rather than an argument list? Well, really nothing. As you can see here, if I remove the element identifier of our list, it'll print the entire list for each iteration. Thank you for checking out this video, and I hope it helped your understanding of how we can pass lists into Python functions. Hi everyone, in this video I want to talk about something that is going to be extremely useful over the course of your time spent learning and using Python.
Accepting user input is incredible and allows us to make our codes behave in certain ways according to whatever the user needs. For example, let's say that you are creating an online ordering system that determines what toppings your customer wants on their taco. So, the user will type no tomatoes, for example. This input of no tomatoes will then be used in our print statement to the screen that our workers assembling the taco will see. Although this is rather a trivial example, this should get you thinking about all the ways in which inputs can be used. So, now that we have a brief understanding of why user input is very important in many Python purposes, how do we go about accepting and using a user's input within our Python codes? The general process for accepting a user's input will go something like this. When your code starts, it'll run through all the code above your line where you ask for a user input. When you hit the line asking for user input, your program will stop and prompt the user for an input. The user will make an input. After the user enters this input, the Python program will begin going through the remaining code. I should note that after Python takes the user's input as a variable, you can use it for whatever you wish, whether that be for a print statement, an if-else statement, or really anything else you can think of. So, let's get into how to actually accept and use user inputs now. To accept a user input, you begin by typing out a variable name. This will be what you call whenever you need to access the data that the user entered. So, just like any other variable, we write equals and then input, which tells Python, hey, at this point, I need something from my user. So, in the brackets, we create a string and tell the user what we want to know. And it is really that simple. Let's do a quick example now so that you can better understand what this actually looks like. Let's tell a user to tell us their name and their age. Then we can print this back to them. So let's create two input variables for the user to give us the information that we require. Then our print statement here at the bottom is just going to work like every other print statement we used previously. So let's create a simple F string to reprint the information. Now we can run our program, and as you can see here, we are prompted to enter our name and age as expected. And there we go. We now have a working Python program that will accept information from our user, and we use that information given to us to create a useful print statement. There's one other thing that I wish to add though. All of the information received from the user is stored as a string, even the age that we took in. Therefore, if we wanted to take our user's age and see how old they will be in, say, 7 years, we will receive an error as we are trying to add a string to an integer. Therefore, we need to convert the data type of this variable to an integer, and then we can use this newly stored variable to add our 7. So, this is just something to watch out for if you are accepting numerical inputs from your user. Hi everyone, in the previous few videos, we talked about functions in Python. Now we are ready to get a bit deeper into all the amazing stuff we can do with functions in Python. However, first we need to understand how to use the Python functions the best we can. To do this, we are going to be talking about the 3 different argument types that we can use in our Python functions. Let's start with the one that we are already familiar with, and this is often called FARGs, which stands for formal arguments. I say we are familiar with these as we have been working with them already in the previous couple videos. These are the arguments that a user must give us in order for our function to operate properly. So, for example, if we are looking to create a simple little database for everyone who visits our veterinarian center, we could create a super simple function that just expects the owner's first and last name. Just to be clear, these parameters listed here, first and last name, are the formal arguments. Formal arguments here need to be satisfied by the user. If they do not give enough information, then we will receive an error as our Python function was expecting, in this case, 2 arguments from our user and not 1. Likewise, with formal arguments, we cannot give our function too many arguments as that will result in another type error. So, in recap, a formal argument, or FARG, is just a necessary argument that we require from our user before we allow the Python function to execute its nested code. So, now that we have a broad understanding of what FARGs are, the next one we will be talking about is just called args, or arguments. And as you can see here, there's an asterisk in front of it. This is called the unpacking operator. And this will allow our Python function to accept and unpack a tuple from our user using positional arguments. I will have a link to a keyword and positional arguments video in the description below, so check that out if you are unsure what they both mean. So let's say that we want to create a super simple calculator that can add any numbers that our user gives it. So let's create that right now using args. So our simple function here will accept any number of arguments given to it by our user in the order that we give it to it, which isn't really important in this example. However, it could be in one of your future Python codes, so just keep that in the back of your head. So let's give our function a bunch of numbers here, and as you can see, it does sum up all of our numbers no matter how many arguments we throw at it. Alright, so let's move on to our last type of argument that we will be talking about in this video, and these are called kwargs, or keyword arguments. These essentially create an empty dictionary in our Python function that our user can choose to fill with whatever information that they want. So let's go back to our earlier example of running our veterinarian clinic. Let's create two formal arguments here at the beginning. We do this because we deem it necessary to know at least the name of our client. Then let's put in this keyword argument called additional info. So to see how this works, let's input some values here, and it should make more sense. As you can see here, we can just continue to add as many key value pairs to this dictionary as we want. Therefore, keyword arguments are excellent for building user databases. Another thing I want to add is that there are two ways in which we could fill in this vet form clinic information. Firstly, we could just fill in the two formal arguments, first and last name, by entering two strings at the beginning of our function call like so. However, you could also retrieve them using explicit keyword arguments like so. Both are valid. So, we should also quickly talk about what we need to do when we want to, say, have all three argument types in our function. How do we go about entering this? The best way to accept all three of these different arguments is through the following. First we accept vargs, and then we accept args, and lastly kwargs. So, let's do a quick example to ensure that you fully understand. Let's say that someone wants to learn with us here at Study Session, and they are wondering what courses we offer. And for speed, we will only enter a few courses here and not every one that we offer. So let's define our function and the arguments in the way that we just discussed previously. Then we can enter some data about Study Session, such as our courses and the number of subscribers. Now let's more closely examine our print statement. As you can see here, we first have our formal argument printed out. Then we have our tuple of courses from the arguments, and then lastly, we have our dictionary printed from the keyword arguments. Just one thing to note is that the order we define these types of arguments in our function definition actually does matter. For example, if we decided to put args after kwargs, we will get returned a syntax error, so just be careful of that. Alright, so you now should have a broad understanding of what these three types of user arguments are. In summary, formal arguments are necessary arguments, args are just a way of accepting any number of positional arguments from our user, and lastly, keyword arguments allow us to generate a dictionary that can be filled with any relevant data using key value pairs. Hey everyone, in this video we're going to be talking about what classes and instances are within Python, and how we can create our own classes and instances. So what is a class in Python? Well, classes allow us to create a type of an object and then create instances of that object. But what does that even mean, you may ask? Well, think of the object we're creating as, let's say, a car. In this class, we would define everything we know about cars. So, what do we know about cars? Well, typically they have a manufacturer, a weight, color, year it was created, and these are just a few that we could think of. Then we have instances of that class, which are branches off the main tree, if you will. So, for our car class, this could be like a 2017 Honda Civic, or a 2013 Volkswagen Jetta. So, when we create our class, we are collecting all defining characteristics of our new object that we can think of. Then, our instances are the items that can be defined by our class that we just created. We should also mention two other things quickly. That is, what is a method and an attribute of a class? So, a method within a Python class is a function that is a part of that class. Everything we previously learned about Python functions will apply to these methods. We are now just calling them methods because they are part of classes and not a standalone Python function. Attributes of a class are one of the defining characteristics that we talked about earlier. So, for some example, if we had some instance, like our 2017 Honda Civic for example, of our car class, then the weight would be an attribute of that instance of that class. Alright, so now that we have an understanding of what classes, instances, methods, and attributes are, let's create an example so that we can see how all this looks in actual Python code. The simplest class that we could make is just an empty class. To do this, we must define the class, so we do this by saying class and car, for example. Then in the nested code below, we just put a simple statement of pass, and this tells Python that our class is going to be an empty class. However, an empty class with no attributes and methods isn't too exciting. So let's add in a few attributes and methods to our class. We do this by creating a method, which remember is a function within our Python class. So the method we use at the first here is called init, or initialize, if you will. And it has 2 underscores on either side. We also must add in a parameter here called self, which will take our future instance's name as an argument for this parameter. This will make more sense shortly if you're still a little bit confused on it. Now, any other attributes we wanted to define for this class can be added as parameters here in our init method, like so. Let's add everything we listed earlier in the video about cars here now. Now, we just need a few statements that will take in the argument given to the init method and allow that to equal a variable, like so. Now that we have our car class created, which remember is basically just a layout or a blueprint if you will, for our future instances of that class. So let's create 2 instances of our car class. We begin by giving a name to our instances, so let's say Civic 2017 and Jetta 2013, as these are just 2 instances of our car class. Now, we type equals and then our class name, which is our way of telling Python this variable, Civic 2017, is going to be an instance of that car class, and that is how Python knows what is required for us to enter into these brackets here. Just note that you do not give an argument for the self parameter which we mentioned earlier. Python will automatically take the variable name, Civic 2017, as the argument for the self parameter. Then we enter our arguments for the attributes in order. Now that we have entered all of our relevant parameters, what would happen if we just printed this instance? Well, it just tells us that our object is stored in the memory. And if we actually print both of these instances, you can see that they point to different spots on the memory, and this is because they are 2 instances of the same class, but they are not the same. We can also print out specific things from our class, specific attributes, through adding a dot and then the name of the attribute you wish to call and print. So, if we wanted to know the color of our 2017 Civic, for example, we would enter this print statement here to achieve that. In the coming videos, we will cover much more about classes and instances, as there is a ton you can do with them in Python. This video was just meant to serve as an introduction to both the classes and instances within Python.
Hey everyone, in this video, I just want to clarify the difference between class and instant variables in Python. If you missed our previous video on classes and instances, I recommend you check out that video first, and I will leave a link in the description below for you to do so. So, quickly, a class in Python is a type of object that allows us to create a template of literally anything we want, whereas an instance is a copy of that class, just with the values filled in by whatever makes that instance different from another instance of that same class. So, we can think of some things that we would tell someone if we were describing a car. Things like the manufacturer, the color, the year, the mileage, the number of doors on the car, things like that. And that is our class. Whereas an instance takes that template generated by the class and actually gives it values. So it could describe a 2015 Honda Civic, for example. So, now after that quick review,
what is a class variable? And what is an instance variable? Well, a class variable is a variable that is defined within our class, or within our template, if you will. And this variable will be inherited by our instances as they are created using the class template. So, if we wanted to know what type of vehicle our class is defining, we could say that the class variable of vehicle is equal to car, and all instances of this class will inherit that. Obviously, this example is a bit silly, but I hope it makes it clear to you what a class variable is. Okay, so if a class variable is a variable that is given to all instances of a certain class, well, then what is an instance variable? Well, if you think about the variables under our init method here, and the ones that we considered, well, they're going to be unique to each instance of a car class, right? If we had a lot of cars to sell, all the instances, the unique cars, would all have varying manufacturers, years, mileage, and things of that nature. But they still all fall within the class of car. So, the unique variables we associate with an instance of a class are called instance variables, which should make sense with the name, right? They are variables that change with each instance. Therefore, instance variables. Same as for class variables. They will be unique to one class, but since instances are created from that class, they inherit the class variables when they are created. To access our class and instant variables in, let's say, a print statement, it can be done like so. Let's print a class and instant variable from our previously created Civic 2015 instance. To do this, we just call the instance and then tell Python which variable we wish to call. And for this portion, the class and instance variables act identical. As you can see here, just from this print portion, it isn't readily apparent which is a class and which is an instance variable. We could inherently use logic to figure out which is a class variable and which is an instance variable, but my point is that you can call them in the exact same way. Thank you for checking out this video, and I hope it helped your understanding of what a class and an instance variable is in Python, and how you can begin to implement them into your Python codes. Hi everyone, in this video we're going to be talking about a way of handling and working with errors in Python. The method we're going to explore in this video is called try and except blocks. These kind of work like our previously talked about if, else, and elif statements. Here, the try and except blocks of code are a way of handling and working around errors. So we could say if this gives an error, print this. If this does not work, try this other thing. So the best way to cover this topic is through an example. So let's do that. Let's ask our user for their age. Well, as it usually goes, our user found a way to break our program, and they did so by entering a string instead of an integer. The problem here is that our code is simply halted and any code after that section is ignored. We can use the try and except block to get around this complication. Otherwise, any trivial error within our program can cause the whole program to collapse, and as you can imagine, that wouldn't be ideal. So, we add try, to our initial statement, meaning Python will try the nested code here. Then we can add in an except term. This means try the following statement, except, meaning that there was an error present, then it will try the nested code. And as you can see here, although we are feeding our program the exact same information, the error no longer breaks our program, and the 1 is still printed, whereas previously it wasn't. So it stands to reason that try except blocks in Python are incredibly important. So what else can we do with them? Well, we can use these except blocks of code to anticipate potential errors from our users, meaning we can assign certain outputs based on the specific error that a user has caused. So, if we go into our try section here and try to print a simple statement and forget our quotation marks around the strings, for example, we will receive a name error since this variable is not defined. Now, when we add in our try and except blocks, we can see that we receive a name error back out as this is the exception that was triggered. Well, what about other potential errors? Well, we can just add another exception block. Just note that you can only have multiple except blocks when you name them a specific error, like this. So let's call this one a general exception and tell that to our user. We want the more specific errors to be identified first in our nested code, as the general except blocks will catch all the errors that the specific exception blocks would too. So when we run this program again, we can see that the name error is caught and identified, but the program still continues to run. If we wanted to test that the other exception block worked, we could add a math error, like so, and as you can see, we get a general error now. Now that we have an idea of how try and except blocks work and can be used to handle errors in Python, what else can we do with them? Well, if we want to test something, ensuring there's no errors, then continue on, we just need to add an else block. So, if our nested code in the try block didn't present any errors, so if our user entered the information correctly in this first example, then we pass right by the exception blocks because they weren't needed, and Python will continue to execute the information in this else block here. So, for example, let's print back to the user their age as it was entered correctly. And as you can see, there are no errors presented. Lastly, we have one last block to go over, and that is the finally block. The nested code here will be activated whether there is an error presented to the user or not. So, to prove that, let's add a statement saying have a good day to our user. Now, let's initiate a name error by giving Python a string instead of an integer. And as you can see here, we get our error and then the nested code from the finally block, but not the else block. Fixing this error, we see that we do get the nested bit of code in the finally block either way. Thank you for checking out this video, and I hope it helped your understanding of how we can use try and except blocks to better understand and handle errors within our Python codes.